Hi everybody, let's solve by combinations. This is, again, another name for solving by elimination or solving by addition, but we're going to add one more step today to make solving by combinations just a little bit harder. So on your classwork, you have a story problem. Sonia bought 5 oranges and 3 bananas for $1.75. Ellen bought 10 oranges and 7 bananas for $3.80. We're asked to find out the cost of an orange and the cost of a banana. So as always, the first thing we want to do for this story problem is define our variables. I'm going to say that X is the cost of a banana, of an orange, sorry, and then Y would be the cost of a banana. So again, I don't want to just say X equals orange and Y equals banana, because then I'm asking myself, does that mean how many bananas? How the cost of a banana? This way I'm sure I know this means the cost of a banana and the cost of an orange. Okay, let's go back to our story problem. Usually one sentence in the story problem is going to translate to one equation. So the first sentence says Sonia bought 5 oranges and 3 bananas. So we don't know how much one orange cost, but we know that 5 of them would cost 5x. And we don't know how much one banana costs, but if we bought 3 bananas, then the cost of them would be 3y. And altogether, Sonia spent $1.75. Okay, the next sentence says Ellen bought 10 oranges, so this is going to be similar. 10 oranges and 7 bananas. And she spent $3.80. So we need to solve this system. We could do it by graphing or by substitution, but today we're going to solve it using combinations. Now the first thing that I notice, if I were to add these two equations together right away, I would not be eliminating any variable. So if I did add them together, I would still have an x and a y, but I need to eliminate a variable in order to find the value of the other one. So we're going to have to do something to this equation first. Instead of adding these two together, I might need to alter one of the equations and multiply that equation by something so that I can add the two together and maybe then eliminate it. Now I'm noticing that if I just were to look at the x's here, I have that a 5x and a 10x, and I could see that maybe if I were to multiply that top equation by a -2, I would end up with a -10x. And that way I would be able to eliminate x when I add these two together. So last time we talked about how we are able to multiply one entire equation by any number we want, and we multiplied some by -1, or we subtracted by multiplying by -1. Today we're going to multiply by -2, and watch what happens when I do that. 5x times -2 is -10x. 3y times -2 is -6y. And $1.75 times 2 is going to be, or times -2 is -350. Now when I add these two equations together, I'm just going to add these two equations together. I changed the top one and I wrote it underneath there in the blue. 10x plus -10x, this is the problem I'm doing right here. 10x plus -10x is 0x. I have eliminated the x's. 7y plus -6y is just 1y. And $3.80 plus -350 equals 30 cents. Oh, so y equals 30 cents. Now, does that make sense for this problem? It does. Look back up at the top. Y was the cost of a banana. Could a banana cost 30 cents? Absolutely, that makes sense. Now let's find out how much an orange costs. We can plug this 30 cents back into either one of these equations. In fact, we have 3 choices now. You could go into there, or the original first one. In fact, I am going to plug it into the original first one just because it's a little bit simpler. So I'm looking for x, but 5x plus 3 times 30 cents, because now I know that y equals 30 cents, is going to equal $1.75. 3 times 30 cents is 90 cents, so 5x plus 90 cents equals $1.75. If I subtract 90 cents from both sides, I get that 5x equals 85 cents. And that tells me that x equals 17 cents. Does that value make sense for this problem? Sure, an orange could totally cost 17 cents. That does make sense. So let's do another problem where we have to do a combination, but we need to multiply one of the equations by something first. So I'm going to do number 2. Tricia and Byron are washing and vacuuming cars to raise money for a class trip. Tricia raised $38 washing 5 cars and vacuuming 4 cars. Byron raised $28 by washing 4 cars and vacuuming 2 cars. And we need to find the amount they charged to wash a car and to vacuum a car. So that last sentence helps us to define our variables. X is going to be the cost of a car wash. Not just how many times they wash a car, but the cost of a car wash. And Y is going to equal the cost of vacuuming the car. And so now we can set up our system of equations. We can write 2 equations to represent this word problem. Let's look at the second sentence and write an equation for it. Tricia raised $38 washing 5 cars and vacuuming 4 cars. So 5 times the cost of washing a car would equal how much she made by washing 5 cars. So 5x. She vacuumed 4 cars. We don't know how much she charged to vacuum 1 car, but we know that she did it 4 times. So 4y is going to be the cost of vacuuming 4 cars, and she made $38 by doing that. Now let's go on to the next sentence, which is going to give us another equation. Byron raised $28, so I'm pretty sure it's going to equal $28. He washed 4 cars, and he vacuumed 2 cars. So that makes our system of equations right there that we need to solve. We could solve it by graphing or by substitution, but we're going to solve this by linear combinations or addition. And again, if you were to just add these 2 equations together right away, you would not be eliminating any variables. So we do need to tweak this a little bit. I can see by looking at the y's that one is a multiple of the other. And so I am going to multiply the entire second row by -2. The reason I want to do that is because I would like to have the same coefficient on the y's with different signs. The same coefficient, different signs. So I'm going to multiply this second row by -2. I'm going to rewrite everything just because this is getting a little messy. So the first row I'm not touching at all. It stays the same. The second row I'm going to multiply by -2 so that I can end up with a -4 in front of the y, and that will help me eliminate the y's. So 4x times -2 is -8x. 2y times -2 is -4y, which is what we wanted. And then 28 times -2 is -56. Now when I add these 2 equations together, I will eliminate the y's because they have the same coefficient with different signs. Okay, so 5x minus 8x is -3x. 4y plus -4y is 0y. We've eliminated the y's. And 38 plus -56 equals -18. If I divide both sides by -3, I get that x equals 6. Does this make sense for this problem? 6 is x, which is the cost of a car wash. Does it make sense to charge $6 for a car wash? Yes, that is a common sense answer that does make sense. Let's find the cost of vacuuming the car. So again, I could take this 6 right here for x, and I could plug it into either of the original 2 equations or even the new one that I altered by multiplying by -2. It totally does not matter. I am going to choose to plug it back into, let's just take the first one. So then I will have 5 times 6, because x is 6, plus 4y equals 38. 5 times 6 is 30, plus 4y equals 38. Subtract 30 from each side, you get that 4y equals 8. Divide both sides by 4 and y equals 2. 2. Does that make sense for this problem? Y is the cost of a vacuum. Should someone charge $2 to vacuum your car? I think it's a great bargain, but sure, that makes sense for this problem. Okay, one more set of equations we can set up. The third story problem. On Monday, Arnold paid $3.40 for 3 donuts and 2 hot chocolates. On Tuesday, he paid $3.60 for 2 donuts and 3 hot chocolates. And on Wednesday, he bought 1 donut and 1 hot chocolate. And we want to know what was his bill for 1 donut and 1 hot chocolate. So again, the last sentence helps us understand what are we looking for. If we want to know the cost of 1 donut and 1 hot chocolate, we first need to find the cost of 1 donut, then we need to find the cost of 1 hot chocolate. So our variables are going to be, maybe x would be the price of a donut, and y would be the price of hot chocolate. And again, I like to say the word price or cost on there so that I remember I'm not finding how many donuts he bought, but I'm finding the price of the donuts. Okay, let's set up an equation. On Monday, Arnold paid $3.40 for 3 donuts and 2 hot chocolates. So 3 donuts, I don't know the price of 1 donut, but 3 donuts would cost 3x. I don't know the price of 1 hot chocolate, I'm just calling it y. So 2 hot chocolates would be 2y, and he spent $3.40. Now on Tuesday, this is a new day, we're going to write a new equation. He paid $3.60 this time for 2 donuts and 3 hot chocolates. And there we have our system to solve. But should we solve it by substitution? Nah, that would be hard. Should we solve it by graphing? Oh, that would take way too long. Neither one of these are in slope-intercept form. Let's solve it by linear combinations, but this time we have a problem because none of the coefficients are multiples of each other. What we're going to end up doing this time is multiplying each equation by another number. So this is kind of like what you do when you're trying to get a lowest common denominator when you're doing fractions. So we're going to look at these 2 coefficients. Right now I have a 2 here and a 3 here. If you wanted to eliminate the x's, that is completely fine. In fact, maybe we will. We'll eliminate the x's this time because I did the y's last time. So let's look at our coefficients. We have a 3 here and a 2 here. What would I need to multiply that top equation by, and what would I need to multiply the bottom equation by so that those coefficients would be the same number, but one would be negative and one would be positive? So I'm kind of thinking in my mind, like if this was 1/3 plus 1/2, what would I do to get the lowest common denominator? Oh, it would be 6. That's like the same idea. Because 2 times 3 is 6. So I'm going to multiply this top row by 2. And I'm going to multiply the bottom row by 3. But that would give me a 6 in both places. So what I'm really going to do is multiply by -3 so that I can have a -6 on the bottom so that I can just add these 2 equations together and I don't have to think about subtracting and worrying about the negative sign. So what does this look like when we multiply the top row by -2? 3 times -2 is -6x. 2y times 2. Oh, my bad, I totally did that wrong. Let's start over. 3x times 2 is 6x. 2y times 2 is 4y. And $3.40 times 2 is $6.80. Now, second equation. 2x times -3 is -6x. That's where we're getting the negative 6 from. 3y times -3 is -9y. And $3.60 times -3 is -1080. I was just thinking that this looks confusing like an x instead of a times, so I like to write it in parentheses, maybe with a dot even, to show like that. Okay, Let's go back to our system. We are going to solve this by adding the two equations together. Remember, that is called linear combinations. So when we do that, we will have 6x minus 6x is 0x. Now we have eliminated the x's. That's what we wanted to do. 4y plus negative 9y is negative 5y. And 680 minus 1080 is going to equal negative 4. Divide both sides by negative 5, and you get that y equals 80 cents. Does that make sense for this problem? Look back up at the top. Y is the price of hot chocolate. Does 80 cents sound reasonable for hot chocolate? Sure, that could make sense. 80 cents for hot chocolate. So now let's find x by plugging that y back into our original equation. I could go into the top equation, the bottom equation, or even either one of the new equations that I got after I multiplied. It does not matter. You will get the same answer no matter what equation you use, because this point is the solution to all four of these equations. And so I'm just going to pick the top one just because it's the top one. So 3 times x plus 2 times 80 cents equals $3.40. 2 times 80 is $1.60. And so everything else here is still the same. And I'm going to subtract $1.60 from each side, so I get that 3x equals $1.80. Divide both sides by 3, x equals 0.6, or remember this was 60 cents. Does that make sense for this problem? Yes, a donut could absolutely cost 60 cents. Okay, sorry I had a little typo on number 5. That says negative 2x plus 4y equals 3, and then x plus 2y equals 5. So this is another system to solve using combinations. I could actually do this either way. I could eliminate the x's first or the y's first. It doesn't really matter. I'm just going to choose to multiply the second equation by positive 2 so that my x's will have the same coefficient but with different signs. So I'll be eliminating the x's. If you wanted to choose to eliminate the y's, you might multiply this whole second row by negative 2, and then you'd have a 4y and a negative 4y. Okay, so I'm going to recopy the first line. Negative 2x plus 4y equals 3. And I'm going to multiply the entire second equation by 2, which gives me positive 2x plus 4y equals 10. Don't forget to multiply that constant also by the number. Now, negative 2x plus 2x is 0x. I have eliminated the x's. 4y plus 4y, 8y. 3 plus 10, 13. Yikes. That's a little bit painful, but it's not wrong. We're just going to have a decimal, divide both sides by 8, and I get for y 1.625. Now you're going to plug that number back in, maybe to the second equation. Looks like the simplest one to do. So that x plus 2 times 1.625 equals 5. Multiply by 2, subtract from both sides, you get that x equals 1.75. Remember that what we're finding here is the point where these two lines cross. So x is the y coordinate, 1.75 is the x coordinate, and 1.625 is the y coordinate of our point. Let's do another one. Again, this time my coefficients are not multiples of each other. So that if I want to get a common number in front of either the x's or the y's, I'm going to have to multiply each equation by something. So the first thing to do is just decide, do I want to eliminate the x's first or the y's? I'm just going to choose to do the x's. You could do the y's, and you will get the same answer. Okay, so if I choose to eliminate the x's, I need to multiply. Okay, let's multiply the top equation by 2 and the second equation by negative 3. That way we will have 6 and negative 6 as our coefficients, and then we will be able to eliminate the x's. So if I multiply the whole top equation by 2, I'm going to get 3x times 2 is 6x. 3y times 2 is 6y, and 4 times 2 is 8. Now I'm going to multiply the whole second equation by negative 3. 2 times negative 3 is negative 6x. Again, that's what I'm looking for. I'm looking for the same coefficient with different signs so that I can eliminate that variable. Okay, getting on back, 4y times negative 3 is negative 12y, and negative 8 times negative 3 is positive 24. Now I'm going to go ahead and add these two equations together. 6x plus negative 6x is 0. That was my goal. Yay! 6y minus 12y is negative 6y. And 8 plus 24 is 32. Okay, divide both sides by negative 6, and y equals, let's reduce it and leave it as an improper fraction, negative 16/3. It's a little bit of a mess, but not too bad. Especially when you plug this y back in, I would put that right back into the top equation so that when I multiplied by 3 times negative 16/3, I am going to actually get rid of the fraction. So that's good news. So 3 times negative 16/3 is just negative 16. So now I'm going to add both sides, 16 to both sides, and I get that 3x equals 20. So x must be 20/3. Now again, these are coordinates to a point. Our x-coordinate is 20/3, and the y-coordinate is negative 16/3. If you wanted to change those into decimals, feel free. You're welcome to. I'm just going to leave those as fractions, but this still represents the point where these two lines intersect. Okay, this one's a little bit simpler. I want you to go ahead and pause the video while you try it on your own, and then come on back and see if I got the same answer that you did. Okay, welcome back. I'm going to multiply. Actually, if I were just to subtract these two equations, I would be able to eliminate the y's. But I don't like to subtract because I tend to drop negative signs, so I'm going to go ahead and multiply every term by negative 1. That just changes all the signs. So if I were to add it together right now, I would get 2x minus 5x is negative 3x. 3y plus negative 3y is 0, so yay, I've eliminated the 0. And 4 plus 8 is 12. Remember, I changed all the signs so that I could just add them together, and a negative times a negative is a positive, so now that's a positive 8. Dividing both sides by negative 3 gives me x equals negative 4. Now you can plug in that negative 4 back into either equation. You will get the same answer whether you choose the top equation or the bottom equation. I'm just going to choose the top one. 2 times negative 4 plus 3y equals 4. Remember, I plugged in negative 4 because that's what x equals. We found that over there. So negative 8 plus 3y equals 4. Add 8 to both sides of the equation, and I get 3y equals 12. Divide both sides by 3 to undo the multiplication. Hey look, y equals positive 4. So for my coordinates, I have a negative 4 and a positive 4. Those are my coordinates. That is the point where these two lines intersect. Last problem. This one is set up kind of nicely for combinations because of this negative 2 right here. I can see that it wouldn't be very hard to multiply that second equation by 3 so that I would end up with a negative 6 right there, and then I could eliminate the y's by adding the 6y plus the negative 2y. So let's see what that looks like if I were to multiply this whole second row by 3. I'm going to just rewrite the whole thing. 2x plus 6y equals 7. Timesing the whole row by 3, 3x times 3 is 9x. Negative 2y times 3 is negative 6y. And 5 times 3 is 15. Now it's time to add both equations together. 2x plus 9x is 11x. Adding those y's together gives me a 0, and 7 plus 15 equals 22. That works out nicely because if I divide both sides by 11, I get out that x equals 2. That's great. I'm going to take that 2 and I'm going to plug it back into either equation, doesn't matter which one. Just because I usually choose the top equation, I think this time I will choose the second equation. So 3 times 2 minus 2y equals 5. Again, we're solving for y. We're trying to find out what y is. So 6 minus 2y would equal 5. Let's subtract 6 from both sides. Negative 2y equals negative 1. Divide both sides by negative 2, and y equals 1/2. There we have it. Our x-coordinate is 2, and our y-coordinate is 1/2, or 0.5. I don't care if you write it as a decimal. And so we have solved that system of equations using substitution.